Okay, this is section 1.3 of geometry. So we have postulate 1.5, which is called the ruler postulate. It says that every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. So using this postulate, we can now measure the lengths of segments using a given unit. So we can find the distance between 2 points. The distance between points A and B is the absolute value of the difference of their coordinates, which just means it's the absolute value of A minus B. This value is also AB, or the length of segment AB. Okay, so now we're going to practice measuring segment lengths. So in this problem, we're looking for ST. The coordinate of S is -4, and the coordinate of T is 8. So ST is equal to the absolute value of -4 minus 8. And -4 minus 8 is -12. So ST is equal to the absolute value of -12, which is equal to 12. Remember that absolute values take something that's negative inside and make it positive when you take away the bars. Okay, so let's look at UV and SV. So UV, U's coordinate is 10 and V's coordinate is 14. So UV is equal to the absolute value of 10 minus 14, which is equal to the absolute value of -4, which is equal to 4. So UV is equal to 4. And then for SV, the coordinate of S is -4. The coordinate of V is 14. So SV is equal to the absolute value of -4 minus 14, which is equal to the absolute value of -18, which is 18. Okay, postulate 1.6 is a segment addition postulate. It says if 3 points A, B, and C are collinear, which means they all share a line, and B is between A and C, then AB plus BC equals AC. So let me mark that on here. AB plus BC is the whole thing AC. Okay, so now let's use that segment addition postulate. So if we're told that EG, this whole line here, is 59, and we're given its expressions for EF and FG, we can find what those numerical values are. So I know that EF plus FG is equal to EG, so the two bits added together is equal to the whole. And I know that by the segment addition postulate. So then I can plug in the expressions for EF and for FG, and now I can use algebra to solve for X. Once I solve for X, I need to go back in to plug in to figure out what EF and FG are. So let's try that on our own. Down here we have a diagram, and we're told that JL, this whole thing, is 120. And we need to solve for JK and KL. Okay, so I know JK plus KL is equal to JL. And then I can plug in for JK and KL what their expressions are. So 4x plus 6 plus 7x plus 15 equals 120. Now I can combine my x's, so I get 11x, and I can combine my 6 and my 15, which will give me 21 equals 120. Now I can subtract the 21, which gives me 11x equals 99, and if I divide by 11, I get x equals 9. That's not my final answer. Now I need to plug that x in for each of those segments. So JK is equal to 4 times 9 plus 6, which is 36 plus 6, which is 42. And KL is equal to 7 times 9 plus 15, which is 63 plus 15, which is equal to 78. There we go. Okay, when two numerical expressions have the same value, we say that they're equal. Now that we're working with line segments, if two segments have the same length, the two segments are congruent segments, and we use the equal sign with a squiggly above it. So if AB is equal to CD, then line segment AB is congruent to line segment CD. And that also works the other directions. If they're congruent, then they're equal. But notice that when we're using congruent, we have the lines above our letters, and when we're just using the equal, we don't. Okay. So, are AC and BD congruent? We calculate the length of AC, which is 7, and the length of BD, which is 7. So since their lengths are equal, then they are congruent segments. Okay. They want to know, is AB congruent to DE? Well, AB is equal to the absolute value of -2 minus 3, which is the absolute value of -5, which is equal to 5. And DE is equal to the absolute value of 10 minus 14, which is equal to -4, the absolute value of -4, excuse me, which is equal to 4. So no, AB is not equal to DE. So line segment AB is not congruent to line segment DE. And then part B says, to find AC in problem 3, suppose you subtract -2 from 5. Do you get the same result, and why? Yes, we do, because what they're doing is flipping the subtraction inside. So if we were looking at AC, usually we would take the absolute value of -2 and subtract 5. But they're asking, is it okay if I do 5 minus -2? And it is, because what that is doing CA, and we know that with line segments, AC is equal to CA. That's the exact same line. They're exactly the same. That's why I can use an equal sign. And so yes, that would be an okay way to do it. Okay, the midpoint of a segment is a point that divides the segment into two congruent segments. A point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect the segment. That point, line, ray, or segment is called a segment bisector. So if we look here, the lines, the little dash marks tell us that AB is equal to BC. So B is the midpoint. And then line L goes through point B, so L is a segment bisector of AC. Okay, so here we have a problem, and Q is the midpoint, and we need to find PQ, QR, and PR. Well, if it's the midpoint, it means it splits it in half. So that means that PQ is equal to QR. So I can set those equal and plug in their expressions and use algebra to solve. And again, I'll solve for x, and then I need to go back and plug it in into the expression for PQ and into the expression for QR. And then I can use the segment addition postulate to figure out what PR is, because I know that PQ plus QR is equal to PR. Oops. Okay. Question A says, is it necessary to substitute 8 for x in the expression for QR in order to find QR? So I had already found PQ, and I could have saved myself some algebra here if I remembered that PQ is equal to QR, since Q is the midpoint. So once I solved for PQ and got 41, right then I know that QR is equal to 41. Alrighty. And then let's try one on our own. So U is the midpoint of TV. What are TU, UV, and TV? Okay, so I know TU is equal to UV. So 8x plus 11 is equal to 12x minus 1. So if I add 1 to both sides, I get 8x plus 12 is equal to 12x, and then I can subtract that 8x, which gives me 12 is equal to 4x, and then if I divide by 4, I get that x is equal to 3. Now I need to go back and plug that in. So TU is equal to 8 times 3 plus 11. 8 times 3 is 24 plus 11, which gives me 35. So TU is 35. And since TU is equal to UV, I know that UV is also 35. And then I know that TV is equal to TU plus UV, which is 35 plus 35, which is equal to 70. Okay, our lesson check. The point on ray DA, remember DA means that it starts at D, starts at D and goes towards A. It's on that ray. The point on DA that is 2 units from D, so 1, 2, that's B. B. 2 points that are 3 units from D. If I count 3 to the right, 1, 2, 3, I get G. And if I start at D and count 3 to the left, 1, 2, 3, I get A. And then the coordinate of the midpoint of AG. So AG is 1, 2, 3, 4, 5, 6 segments long. So I need to go 3 segments to find the middle. So 1, 2, 3. Coordinate of the midpoint is D, and the coordinate is 0. And then for a segment congruent to AC. AC is 2 segments, so I could choose any segment that's 2 long. So DF is congruent to AC. I could also say EG is congruent to AC. And there's a lot of other options, but there we go. There's your homework.